How big is that thing under your scope? With a ruler and the back of an envelope, you can get a pretty good estimate. Look at the millimeter side of your ruler under your lowest power objective. Typically that objective is labeled 4x magnification, which when multiplied by the magnification of the objective lens, which is 10x, gives you a total of 40 times magnification. Which means that through the microscope, you'll usually see something like where 3 or more hash marks cover the entire field of view. This means that for our scope, the diameter of the field of view at 40x is approximately 3 millimeters. It looks like it's a little bit more than that, so let's call it 3.1 millimeters. But what if the scope was set to the 40x objective instead? That's 400 times magnification. The field of view at that magnification would probably look like this, with a single hash mark on the ruler taking up most of the field of view. So since it's impossible to measure with the ruler at that magnification, instead we're going to have to do some math. At 40 times magnification, the diameter was 3.1 millimeters. But now we've switched to the 40x objective, which when you account for the ocular lens means we're looking at 400 times magnification. So how big is that? To figure out how much we zoomed in, let's take the new magnification and divide it by the old magnification. So that's going to be 10 times more zoomed in than we were before, which means that the diameter is now 10 times smaller. So if we take our 3.1 millimeters and divide it by 10, we get 0.31 millimeters. Since decimals are annoying and the metric system is amazing, biologists usually convert this size into micrometers. A micrometer is 1,000th of a millimeter. They usually write out the conversion by multiplying by a fancy version of 1. 1,000 micrometers over a millimeter, which is 1 since these two values are equivalent. The units cancel out, and you're left with your converted answer, 310 micrometers. But that's the length of the entire diameter of the field of view. What if the cell you're looking at only takes up that much of the field of view? Visualize approximately how many cells could fit across the diameter. In this case, about 4.4 cells. And then divide the diameter by that number, leaving us with the approximate size of the cell at 71 micrometers. So let's try a practice problem. Say you look at a ruler through the 4x objective of your scope and you see this. Say that's a diameter of about 2.8 millimeters. Under the 100x objective, your cell looks like this. So about 3.3 of a cell can fit across the diameter. How big is the diameter of the cell? Pause the video here to see if you can figure it out. With the 4x objective in place, the diameter of the field of view is about 2.8 millimeters. What would it be under the 100x objective? How much did we zoom in? 100 divided by 4 is 25x, so we're 25 times more zoomed in than we were before. So we take those 2.8 millimeters, divide by 25, we get 0.112 millimeters, which we then need to convert to micrometers. So we take our 0.112 millimeters, we multiply it by a fancy version of 1, units cancel, and we're left with 112 micrometers. But that is the diameter of the whole field of view. And we're interested in a cell that can lay 3.3 times across the diameter. So divide by 3.3, and we get the individual cell is about 34 micrometers across. Okay, one final practice problem. Say under the 4x objective, the field of view is 3.1 millimeters. Under the 40x objective, about 11 cells could lay across the field of view. About how big are those cells? Pause here and try to solve it.